Here we have a problem in trigonometry. Okay, let's go with the question. Find the principal solutions in degrees of the equation 3 secant square x negative tangent square x negative 4 equals to 0. Here we have a trigonometric equation. In this equation, we have the variable x. So solving this trigonometric equation means we have to find the value of the variable x over here. And the variable x represents the angle measure. And when I solve for x, the value I'm getting for x has to be in degrees according to the question. And also the question says find the principal solutions. What is meant by principal solutions? The angle measure I'm getting for x over here must be within the interval, that is 0 degree comma 360 degree. So when I get the angle measure for x over here is in this interval, then it can be considered as principal solutions. Here in this interval, I have taken square bracket on the left side over here. I have taken parenthesis on the right side over here. That means the left side is closed, the right side is open. That is, 0 degree is included, but this 360 degree is not included. So that is, it can be written as 0 degree less than or equal to x less than 360 degree. So this is what is meant by the square bracket on the left side and the parenthesis on the right side. Why don't we include 360 degrees? Because like when I draw the 4 quadrants over here, here we have 0 degree, here we have 90 degrees, here we have 180 degrees, here we have 270 degrees, and here we have 360 degrees. So we have both 0 degree and 360 degrees at the same position. So that's why we don't include this one. We just include only the starting value is 0 degrees. Okay, now let's start solving this trigonometric equation. That is 3 secant square x negative tangent, 2 tangent square x negative 4 equals to 0. In this trigonometric equation, we have two different trigonometric ratios. One is secant and other one is tangent. Whenever I want to solve a trigonometric equation, it has to contain only one trigonometric ratio. But here we have two different trigonometric ratios, secant and tangent. So how do you have to get this equation in just one trigonometric ratio? For that, we can use the Python identity, that is secant square x negative tangent square x equals to 1. Okay, now let's solve for secant square x in this equation. For that, we have to add tangent square x to both sides. Let me do it. So when I add tangent square x to both sides, so this negative tangent square x, positive tangent square x will cancel. I'm getting secant square x equals to 1 positive tangent square x. Okay, now what I can do is I can plug in this 1 positive tangent square x for secant square x over here. Then I'll be getting the given trigonometric equation in just one trigonometric ratio, that is tangent. Okay, let me do it. So 3 times 1 positive tangent square x negative 2 times tangent square x equals, negative 4 equals to 0. Okay, now we can distribute this 3 to 1 and tangent square x. When I do such a distribution, I'm getting 3 positive 3 times tangent square x. Negative 2 times tangent square x, negative 4 equals to 0. Here on the left side, we can combine the like terms. So this 3 and this negative 4 can be combined because both of them are numbers. And also this one can be combined because both of them contain tangent square x. Okay, first let me combine this 3 tangent square x, negative 2 tangent square x. Then I'm getting 1 tangent square x. When I combine this 3 and negative 4, I'm getting negative 1 equals to 0. Okay, now let me add 1 to both sides. When I do so, this negative 1 positive 1 will cancel. I'm getting tangent square x equals to 1. Okay, now this tangent square x can be written as tangent x whole square equals to 1. Okay, let me continue over here. That is, we have tangent x whole square equals to 1. Okay, now to get of the square, what I have to do is I have to take square root on both sides. Whenever I take square root on both sides of an equation, for one of the square roots, I have to consider a positive or negative sign. Usually consider a positive or negative sign for the square root which contains number inside. So this is a square root which contains number inside. So for this square root, we can consider positive or negative sign. On the left side, the square root and square will cancel out. I'm getting tangent x equals to positive or negative. The evaluation of square root of 1 is just 1. Okay, then we can split up this one into two equations. So one time we can write for positive sign, other time we can write for negative sign over here on the right side. Then I'm getting tangent x equals to 1. The other equation is tangent x equals to negative 1. Okay, now we have to solve these two equations for x, and the angle measure we get for x has to be in degrees, and also it has to be in the interval 0 degree comma 360 degrees, as I explained earlier, to get principal solutions. Okay, on the next page we can solve these two equations one by one. First, let me start solving this first equation, tangent x equals to 1. Okay, let me go to the next page. So we have tangent x equals to 1. Okay, here to solve this first equation, what I'm going to do is I'm going to consider the four quadrants. So let me draw the four quadrants. Okay, let me draw it over here. So here we have 0 degrees, here we have 90 degrees, and here we have 180 degrees, here we have 270 degrees, and the same portion we have 300, I mean the same portion of 0 degrees, we have 360 degrees. We don't have to mark it. And here this is the first quadrant, and this is a second quadrant, and this is a third quadrant, and this is a fourth quadrant. Now we can consider the ASTC concept. ASTC means A is for first quadrant, S for second quadrant, T for third quadrant, and C for fourth quadrant. This one can also be remembered as all silver teacups, or all students take calculus. That is, we have A in the first quadrant, S in the second quadrant, T in the third quadrant, and C in the fourth quadrant. So why do we have A for the first quadrant? What does A stand for? Actually, A stand for all trigonometric ratios are positive in the first quadrant. The second quadrant we have S. S means the trigonometric ratio sine and its reciprocal cosecant are positive, the rest are negative in the second quadrant. In the third one, we have T. T means tangent and its reciprocal cotangent are positive, the rest are negative. In the fourth one, we have C. C means cosine and its reciprocal secant are positive, the rest are negative. Here in this equation, the value of tangent is 1. So the value of tangent is 1 means I will have this angle measure x either in the first quadrant or in the third quadrant, because in these two quadrants tangent is positive. Because in the first quadrant all trigonometric ratios are positive, so tangent is also positive. In the third quadrant tangent is positive. Since I have a positive value over here, so we'll be having this angle measure x in the third quadrant as well. Always it is easier to find the angle measure in the first quadrant. So now we can consider since it's a positive value, we can consider the angle measure x over here in the first quadrant. Using either a unit circle or trigonometric ratio table, we can get the angle measure for which the value of this tangent is just positive 1. When I use unit circle or a trigonometric ratio table on the first quadrant, that is between 0 degree and 90 degree, I'm getting an angle measure that is x equals to 45 degree, for which the value of this tangent is just 1. Okay, here I got the angle measure in degrees because the question says that we have to find the principal solutions in degrees. Otherwise, we can get the angle measure in radians also, that is pi over 4. Okay, now I got the value of x, that is 45. That is when I plug in 45 degree for x over here. That is tan 45 degrees equals to 1. I got one of the solutions for the given trigonometric solutions, that is 45 degrees. So we got this solution in the first quadrant as we discussed earlier. So we have the angle measure x in the third quadrant as well, because in the third quadrant tangent is positive, because here we have a positive value over here. How do we have to get the angle measure in the third quadrant? So for that we have to use the angle measure 45 degree as a reference angle over here. So here we can use this 45 degree as a reference angle. So now to get the angle measure in the third quadrant over here, now what I have to do is I have to add this 45 degrees to this 180 degrees. When I do so, 180 degree positive 45 degrees. So then when I add them, I'm getting 225 degrees. So I'm getting 225 degrees is the angle measure in the third quadrant, for which the value of this tangent is the same 1. So like in the solving the first equation, that is tangent x equals to 1, I am getting two values for x. X equals to 45 degree and 225 degrees. The first value is in the first quadrant, and the next one 225 degrees is in the third quadrant. Okay, now we can start solving the second equation. Already we got it on the previous page. Okay, let me go to the previous page. That is tangent x equals to -1. Okay, let me write the equation over here. Tangent x equals to -1. Okay, this time we have a negative value over here. So since we have a negative value over here, the angle measure x has to be either in the second quadrant or in the fourth quadrant. Because in the second quadrant, only sine and its reciprocal cosecant are positive, the rest are negative. The rest are negative means the tangent is tangent and everything. It means we have only tangent, so tangent is negative. The fourth quadrant, cosine and its reciprocal secant are positive, the rest are negative. So this tangent is negative. Okay, now how do you have to get the angle measure in the second quadrant and the third quadrant, for which the value of this tangent is -1? For that, what we have to do is we have to assume the negative value over here as a positive value. Let me assume let tangent x equals to 1. So since I assume this negative value is a positive value, now we can consider the angle measure in the first quadrant, because in the first quadrant all trigonometric ratios are positive. So once you get the angle measure for x for this tangent is equal to 1 in the first quadrant, you can use that angle measure as a reference angle in the second quadrant and the fourth quadrant to get the angle measure x for which the value of tangent x is -1. But already we have solved this equation tangent x equals to 1 over here in the first quadrant, and we got that x equals to 45 degrees. Now let me use this 45 degrees angle measure as reference angle in the second quadrant. Let me draw the terminal side of the angle. Okay, here we can consider this 45 degrees as reference angle. Now to get the angle measure in the second quadrant, what I have to do is I have to subtract this reference angle 45 degrees from this angle measure 180 degrees. Then I'm getting 180 degrees negative 45 degrees. When I subtract 45 from 180, I'm getting 135 degrees. Okay, now I got the angle measure x in the second quadrant, that is x equals to 135 degrees, for which the value of tangent is -1. Okay, now let me use the same 45 degrees angles as a reference angle in the fourth quadrant. Let me do it over here. Here we have the reference angle 45 degrees. Okay, we just started from the angle measure 0 degrees. When I complete one full rotation, the angle measure I'll have over here is 360 degrees. Now to get the angle measure in the fourth quadrant, what I have to do is I have to subtract this reference angle 45 degrees from this 360 degrees. Then I'm getting 360 degrees negative 45 degrees. So when I do such subtraction, I'm getting 350 degrees. Now I got the angle measure in the fourth quadrant for which the value of the tangent x is -1. That is x equals to 315 degrees. Okay, so solving the two equations, tangent x equals to 1 and tangent x equals to -1, I got four values for x, so 45 degrees and 225 degrees from the first equation, and from the second equation, tangent x equals to -1, I got 135 degrees and 315 degrees. So we have all these four values of x are in the interval 0 degrees, 360 degrees. So all these four values of 45 degrees, 225 degrees, 135 degrees, and 315 degrees can be considered as principal solutions to the given trigonometric equation.